In this video, we are looking at example 3 on page 217 of the Maths Handbook and Study Guide for grade 12. Right, the question reads, the equation of a circle is x squared plus y squared minus 8x plus 6y equals 15. Take note, this hasn't been given to us in standard form, so we're probably going to have to complete the square to get the equation in standard form at some point in the question. And the first question says, prove that the point A2 and minus line lies on the circumference of the circle. So there are two ways we can do this. The first way is we simply prove that if 2 and minus 9 lies on the circumference, then this equation will be true. So we start with the left-hand side of the equation, and we're going to substitute x equals 2 for all my x's, and y equals minus 9 for all my y's. So we're going to have 2 squared plus minus 9 squared. Make sure you put the minus 9 in brackets because the negative also has to be squared. Minus 8 times by 2 plus 6 times by y. And what we're trying to do is prove that this equals 15. If that's equal to 15, then that point must lie on the circumference of the circle because the equation is true. And once again, I prefer to use my calculator for this so I don't make any silly mistakes. Minus 2 squared plus minus 9 all squared minus 8 times 2 plus 6, and I wrote y there. That should actually be 6 times minus 9, which gives us an answer of 15, and therefore that is equal to our right-hand side of our equation, and therefore the point A, which is 2 and minus 9, does lie on the circle. Now, the other way to do this is a little bit more difficult in terms of the maths, but what we could do is take our circle and we could complete the square, find the equation of the circle center, then go to point A, which is 2 and minus 9, and then we could use distance formula to prove that the radius is equal to the square root of 15. I'm not going to go do all of that because it's much longer and much harder, but it is another way you could do this question. Right, let's look at question B. Determine the equation of the tangent at point A. So now we do have to go and complete the square. We need to find the equation of the circle in standard form because we need our circle center. So let's start with that. Let's group our x's together. So it's x squared minus 8x plus y squared plus 6y is equal to 15. If you've watched the previous videos, you should be quite comfortable with this by now, that this is x minus 4, or half the coefficient of x, all squared, plus y, half the coefficient of 6 is 3, all squared, is equal to 15 plus 4 squared, or if we do it, plus minus 4 all squared, plus 3 all squared, and that is going to equal to 40. So now we have the equation in standard form, and we know that our circle center is going to be at positive 4 and negative 3. Now, once again, always easiest to draw a picture. So let's quickly draw a circle. And our circle is centered at 4 and minus 3. And point A is 2 and minus 9. So point A is going to lie somewhere over here. Let's draw it a little bit to the side. And we're trying to find the equation of the tangent to the circle at point A. So we're trying to find the equation of that line. So that's going to be y equals mx plus c. We have our point of contact. The first thing we're going to do is find the radius of the gradient of the radius. So my gradient of my radius is equal to y2 minus y1 all over x2 minus x1, and that's going to equal to minus 9 minus minus 3 is plus 3 all over x2 minus x1. We started with the y value at a, so we start with the x value at a as well, which becomes 2 minus 4. And again, let's put that in our calculator. Let's not make any silly mistakes. It's minus 9 plus 3 over 2 minus 4, which gives me a gradient of 3. So that's the gradient of my radius. Therefore, the gradient of my tangent is equal to negative 1 over 3, the negative reciprocal. We swap the 2 and we add a minus. All right, now this question goes y equals minus a third x plus c, and all we have to do is solve for c. How do we do that? We substitute our point of contact in. Be very careful not to substitute your radius in. You have to substitute a point that lies on that line. And the only point we have that lies on that line is A. And don't forget, tell the examiner what you're doing. So we sub it in point A, which is 2 and minus 9. So it becomes minus 9 is equal to minus a third times 2 plus c. And we're going to get c is equal to minus 25 over 3. So therefore, the equation of my tangent is y is equal to minus 1 over 3x minus 25 over 3. And just a note, for finding equations of straight lines, you can also use the formula y minus y1 equals m into x minus x1. I personally prefer y equals mx plus c, but whichever formula you prefer is fine to use. In the next video, we'll be looking at example 4 on page 218 of the Maths Handbook and Study Guide for grade 12.